Welcome to our channel. Today, we're diving into the world of civil engineering to explore the different types of structures that shape our world. From bridges that span vast rivers to skyscrapers that touch the clouds, civil engineering structures are all around us. In this video, we'll be your guide on a journey through the fascinating world of civil engineering structures. Whether you're an aspiring engineer or just curious about the built environment around you, this video is for you. So buckle up and let's get started. Before we dive into specific types of structures, let's talk about why understanding them is so important. Imagine you're a civil engineer tasked with designing a new bridge. You need to consider the type of bridge that would best suit the location, the traffic load it needs to carry, and the environmental conditions it'll face. Each type of structure has its own strengths and weaknesses, its ideal applications, and its own set of design considerations. Knowing the ins and outs of different structures allows civil engineers to make informed decisions about the best type of structure for a particular project. It's like having a toolbox full of different tools. You wouldn't use a hammer to tighten a screw, right? So whether it's a towering skyscraper or a simple retaining wall, understanding different types of structures is crucial for civil engineers to design and build safe, efficient, and sustainable infrastructure. Let's start with the most common type of structure we encounter every day: building structures. These are the structures that provide us with shelter, workspaces, and places to gather. Building structures range from small residential homes to towering skyscrapers, each with its unique design considerations. One of the key factors in building design is the material used. Wood, concrete, and steel are common choices, each with its own strengths and weaknesses. Skyscrapers, for example, require specialized engineering to withstand wind loads and ensure stability. Building structures also need to meet specific safety regulations and building codes, ensuring the well-being of the people who occupy them. So, the next time you walk into a building, take a moment to appreciate the complexity and ingenuity that goes into creating these structures that shape our daily lives. Now, let's move on to structures that connect us. Bridges. Bridges are essential for transportation, spanning rivers, valleys, and other obstacles to keep us moving. They come in various forms, each designed to overcome specific challenges. One of the most iconic bridge types is the suspension bridge, like the Golden Gate Bridge. These bridges use massive cables strung between towers to support the bridge deck, allowing for impressive spans. Another common type is the beam bridge, which uses horizontal beams supported by piers or abutments. Beam bridges are simpler in design than suspension bridges and are often used for shorter spans. Arch bridges, as their name suggests, use arches to support the weight of the bridge deck. Cable-stayed bridges are like a hybrid between suspension and beam bridges. Designing a bridge requires careful consideration of factors like the span length, traffic load, environmental conditions, and available materials. It's a complex process that involves a lot of math, physics, and engineering ingenuity. Let's talk about structures that control and harness the power of water: dams. Dams are massive barriers built across rivers or valleys to create reservoirs, control water flow, and generate hydroelectric power. Gravity dams, the most common type, rely on their sheer weight to resist the force of the water. Arch dams, on the other hand, use their curved shape to distribute the water pressure to the canyon walls on either side. Embankment dams are made of compacted earth and rock fill, and are often used in areas with wider valleys. Dams play a crucial role in water management, providing irrigation for agriculture, controlling floods, and generating hydroelectric power. They're essential for supporting human populations and economic activities. However, dam construction can also have environmental impacts, altering river ecosystems and potentially displacing communities. That's why careful planning and consideration of environmental factors are crucial in dam projects. Let's venture underground and explore the fascinating world of tunnel structures. Tunnels provide passage through obstacles like mountains, rivers, and even undersea straits, making transportation, mining, and utility installation more efficient. Tunnel construction is a complex and challenging endeavor, often requiring specialized equipment and techniques. One common method is the drill and blast method, where explosives are used to break up the rock, followed by excavation and support installation. Another method is the tunnel boring machine, TBM, a massive mechanized earthworm that chews its way through the ground, excavating the tunnel as it goes. Once a tunnel is excavated, it needs to be supported to prevent collapse. Tunnels are used for a variety of purposes, from transportation tunnels for cars, trains and subways, to utility tunnels for water pipes, sewer lines and electrical cables. The next time you drive through a mountain tunnel or ride a subway, take a moment to appreciate the engineering marvel that makes it all possible. Let's reach for the sky and explore the world of tower structures. Towers are tall, slender structures used for a variety of purposes, from communication and broadcasting to observation and even power generation. One of the most common types of towers is the lattice tower, which uses a framework of interconnected triangular sections to create a strong and lightweight structure. Another type is the guyed mast, which uses cables, guys, anchored to the ground to provide additional support to a tall, slender mast. Skyscrapers, while technically buildings, can also be considered tower structures. These super tall buildings use a combination of structural systems, including core and outrigger systems, to achieve their impressive heights while maintaining stability. Towers often serve as landmarks in urban landscapes, defining skylines and providing visual interest. The next time you see a tower, take a moment to appreciate the engineering that goes into designing and building these structures that reach for the sky. Let's talk about structures that hold back the earth: retaining walls. Retaining walls are essential for creating level ground in areas with slopes or changes in elevation. They prevent erosion, create usable space, and provide support for other structures. Gravity walls, as their name suggests, rely on their weight to resist the pressure of the soil behind them. Cantilever walls use a T-shaped design to provide additional support. Sheet pile walls are made of interlocking sections of steel, vinyl, or concrete driven into the ground to create a continuous barrier. Reinforced soil walls use layers of compacted soil reinforced with geogrids or geotextiles to create a strong and stable retaining structure. Retaining walls are essential for a variety of construction projects, from creating level yards to supporting roadways and bridges. They're often hidden in plain sight, but their role in shaping our built environment is crucial. So the next time you see a retaining wall, remember the engineering that keeps the earth in place. While they may be hidden beneath the ground, foundation structures are the unsung heroes of civil engineering, providing the essential support for all the structures we've discussed so far. Foundations transfer the load of a structure to the ground, ensuring stability and preventing settlement. Shallow foundations, like strip footings and pad footings, are used when the soil is strong and the load is relatively light. Deep foundations, like piles and piers, are used when the soil is weak or when the load is heavy. Foundations are critical for preventing settlement, which can cause cracks in walls, uneven floors, and even structural failure. So the next time you admire a towering skyscraper or walk across a sturdy bridge, remember the hidden foundation structures working tirelessly beneath the surface to keep everything standing tall. Let's talk about structures that achieve strength through their shaped shell structures. Shell structures are characterized by their thin, curved surfaces that distribute loads efficiently, making them strong and lightweight. Think of an eggshell. It's incredibly thin, but surprisingly strong because of its curved shape. One of the most iconic examples of a shell structure is the Sydney Opera House. Shell structures are often used for large-span roofs, like stadiums, arenas, and aircraft hangars. They're also used for smaller structures like water tanks, silos, and even some types of furniture. It's a specialized field within civil engineering that combines artistry and engineering to create elegant and efficient structures. Let's step back in time and explore one of the oldest and most enduring structural forms, the arch. Arches have been used in construction for thousands of years, from ancient Roman aqueducts to modern-day bridges and buildings. The beauty of an arch lies in its ability to transfer loads along its curved shape and down to the supports, abutments, at either end. This allows arches to span large distances without the need for intermediate supports, creating open and unobstructed spaces. Arches can be made from a variety of materials, including stone, brick, concrete, and steel. Arches continue to be used in modern construction, often combined with other structural forms to create innovative and visually appealing designs. They're a reminder that sometimes the oldest ideas are also the most elegant and effective. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe for more fascinating insights into the world of civil engineering. We've explored a wide range of civil engineering structures, from the towering skyscrapers that define our cities to the hidden foundations that keep them standing tall. Civil engineering is all around us, shaping the world we live in. So, the next time you cross a bridge, walk through a tunnel, or simply relax in your home, take a moment to appreciate the incredible work of civil engineers who make it all possible.